Hi everyone, welcome to Priya Academy channel. In today's video, we will see chapter 2 in physics, units and measurements, in which 2.2 International System of Units topic. In the previous video, we have seen 2.1 introduction topic. Those who have not watched that video, it would be better to watch that video first and come back here. Link for the first video is given in the description box. Before that, please subscribe this channel. In earlier times, different system of units was used by the scientists in different parts of the world for their measurement, out of which only three system of units were being used for many years till recent times. They are CGS, FPS and MKS. We know that the fundamental physical quantities or base quantities are length, mass and time. Now we will see how the base units for these fundamental quantities are expressed in the three system of units. In CGS, length is expressed as centimeter, mass is expressed as gram and time as seconds. In FPS, length is expressed as foot, mass is expressed as pounds and time as seconds. Similarly, in MKS, length is expressed as meter, mass is expressed as kilograms and time as seconds. Now we will see how these system of units are related to each other. For example, length in MKS is 1 meter, which is equal to 3.3 feet in FPS and also equal to 100 centimeter in CGS. Similarly, mass in MKS is 1 kilogram, which is equal to 2.2 pounds in FPS and 1000 grams in CGS. As you see here, if you try to do the unit conversion from feet to meter, then we get to write like this. We can write 3.3 feet equal to 1 meter or 1 foot equal to 1 divided by 3.3 meter. Of course, we can use calculator to find out this. It will be approximately 0.33 meter. Okay. Yes. But each and every time doing this kind of conversion will be difficult because this conversion involves calculation of this fraction. As you see here, it is difficult to do the unit conversion. Because of these difficulties and due to globalization, the companies working across the globe felt very difficult to carry out their projects in different parts due to this difficult practice of different system of units. Hence, to avoid confusion and to save time, there was a need to unify the system of units. Accordingly, in 1971, General Conference on Weights and Measurements was conducted, in which they found out a new system of units called SI units. The name SI is derived from the French word Système Internationale des Units, in which length, mass and time are expressed as meter, kilogram and seconds. Moreover, that conference developed and recommended symbols, units and abbreviations for all the physical quantities in SI system of units. Another reason for developing these SI units is it is easy to do the unit conversion as it uses decimal system. We have 7 SI base units or fundamental units as you see in this table in SI system. For each physical quantity, we give the units here and its associated symbol here, and this one is the typical symbol. Typical symbols are nothing but the short notation for the base quantity. Now, in this, the base unit mole is the unit for amount of substance, that is amount of substance present in an atom, ion, electron, etc. So while using the unit mole, we should clearly mention whether it is for atom, ion or electron, etc. Alright. In your textbook, in addition to these columns, one more column for the definition of these base units are also present. We will see that now. The definition of meter. But before that, meter should be METRE or METER. Both are correct. METRE meter stands for British English and METER meter stands for American English. Regarding the definition of meter, it has been revised over the years in order to define it accurately. Starting from 1793, it has been again revised in 1799, 1889, 1960 and in 1983. In 1983, meter was formally defined as the length of the path travelled by light in a vacuum in 1 by 29 crores 97 lakhs 92,458 of a second. To illustrate this, consider light as a particle, and when it travels from a time of this much of second, then how much distance it covers, that is 1 meter. But after 2019, this definition has been revised, which is quite complex to understand as a 11th standard student. I gave this in a simple format here. Okay, now we will see the definition of a kilogram. It is also revised starting from 1795, 1799, 1889 and in 1983. After 1983 till 2019, same definition was followed. That is, for nearly 130 years, this definition was used, which states that 1 kilogram is equal to the mass of a platinum iridium cylinder of the international prototype of the kilogram IPK, kept at International Bureau of Weights and Measures at Servais near Paris, France. Which means that 1 kilogram is equal to the mass of the cylinder shown in figure. Okay, where is this cylinder? This cylinder is preserved and present in International Bureau of Weights and Measures. Where it is? It is in Paris, France. That's the meaning. Okay, what is the definition for a second? Definition of second is also a little bit quite complex. So I gave the Wikipedia link for the definition of second as well as the definition of mass in the description box. Those who are interested, click that one and check it. In this table, we give 7 base units. Beside these 7 base units, we give 2 more units, plane angle d theta and solid angle d omega. So before we see the definition of these two, what is plane, what is solid? Plane is a 2D, solid is a 3D. Now in this figure, you can see one rectangular box. It is an example for a 3D. It is also called as cuboid. Similarly, the cylinder is also an example for a 3D. And the sphere is also an example for a 3D. Now consider the rectangular box in which the leftmost corner I will take as the origin, and I will fix the 3 orthogonal axes x, y, z in that corner, so that the length can be assumed to be along the x-axis and the breadth can be assumed to be along y-axis and width can be assumed to be along the z-axis. So that this box has 3 dimensions: length, breadth and width, as you see here. So that's why this is called as a 3D object. Now we will see what is a 2D. Consider the same box in which the length is 100 mm and then breadth is 50 mm and width is some 56 mm, something like that. Now when I change the width, or otherwise when I alter the width, when I decrease the width from 56 mm to 2 mm like this, very much small, then you can see here I got a plane which is having a length of 100 mm, breadth of 50 mm, but the width is very much less, 2 mm. So this kind of object is called as a plane or 2D. So far we have seen the explanation about 3D and 2D. Now we will see plane angle d theta. For that, let us consider a circle. Let's see by the center point of the circle. and r be the radius of the circle. Let us draw another line similar to this radius such that the angle between the two lines be d theta. Then we can cut out this arc separately like this. Then we have another term called as ds. So this ds indicate this arc length. Then there exists the relationship between these three, that is d theta equal to ds divided by r. This d theta is called as plane angle. So plane angle is defined as the ratio between ds and r. This plane angle is expressed as radians, and this formula is very much important because from this only we will obtain the circumference of the circle formula. How? We will see now. So we know that plane angle d theta equal to ds by r. From this we can write ds as d theta multiply r. So for full circle, d theta should be equal to 360 degree or 2 pi radian. So I can replace d theta as 2 pi in the above formula, so that ds equal to 2 pi multiply r. Now instead of writing ds, we can write it as s equal to 2 pi multiply r, because ds is the arc length in which d theta is small. But when you replace d theta as 2 pi for the full circle, instead of writing as ds, we can replace it as s. So this s indicates the circumference of this circle. Now next we will see solid angle d omega. For that, let us consider a sphere from which let us cut out a small portion like a conical shaped one, which is a 3D. In this one, let r square be the distance from the cone tip to the base area. Why it is r square? Because it is a 3D shaped figure, so it should be r square only. Then d omega is the solid angle of this cone. Then we have another term called as dA, which indicates the surface area of this cone. Then there exists the relationship between d omega, area dA and r square, same like as we have seen in the case of plane angle d theta, which is given as d omega equal to dA by r square. This d omega is called a solid angle, which is the ratio of dA and r square, and whose unit is SR, that is steradian. And this solid angle formula is very much important because from this only we will obtain surface area of sphere. How? We will see now. We know that solid angle equal to dA divided by r square. From this we can rewrite dA as d omega multiply r square. Then for full sphere, d omega is replaced by 4 pi because the maximum value of d omega is 4 pi. So when you replace d omega by 4 pi, you will get the same sphere. You will get dA equal to 4 pi multiply r square. Now instead of dA, we can replace as a, because the maximum value of d omega we have substituted as 4 pi, which indicates the full sphere. Then a indicates the surface area of sphere. A equal to 4 pi r square. In this video, we have seen 2.2 International System of Units. In the previous video, we have seen 2.1 Introduction. Those who have not watched that video, I have given that video link in the description box. And in the next video, we will see 2.2a SI units, in which we will see deriving SI units and then general guidelines for using SI units. But before that, those who are not subscribed, please subscribe my channel.